Try to get everything in the right place this morning. Yeah, everybody's getting here better. Well, they opened up the highway, right? Is it better now? Hope so. We just have a little bit to talk about today before you guys get to work on your projects. So we've got the Zoom session going. Hello. Hope everybody had a good weekend. Getting to the dragging down part of the semester, I know. Week 5. So I don't know why, but this seems to be like a long haul, right? Between days off, I guess. So interfaces, ever since we started C#1, I've been saying an interface is what users look at, right? So this is a place where they use the same term for something else. Yay. Totally the same term. Totally not talking about what a user looks at. This is the last part of our object-oriented blitz here of trying to get everything created before we get started. For the assignment that was due Tuesday, you had to have the DLL for your sports team for all the stuff coming up this week. You don't need to worry about that. Just source code in your project, get everything compiled. So we just wanted to practice with that DLL one time, just so you guys know what's out there. You know what you can do with them. You know how to create one if you need to. But for moving forward, you can just pull all your source code into your project so that the debugger will work and everything will give you all happy results. Now on Discord on Friday, I posted most of a sample project. It doesn't have the update stuff, obviously, since it's you. But as a tester, because I felt like we would be better served today with you guys using the time to work on your project as opposed to us working on one together.
So do we need to like copy and paste our code to a Windows form, or can we just use the same file, class library file?
It's totally up to you yes. So if you open your project and just say add existing item and go get those class files, you can do it that way. So it's
fine to leave it as a class library type. Okay, I didn't know that was
your individual projects, you might just want to pull your CS file in to this new one and just have one project, but you can organize it however you like. So if you want to mess with stuff and just experiment, do that too. So whatever makes it move the fastest for you. So the tester that I sent you is by no means perfect or anything like that. It was just something, because I know sometimes it can be hard to get started, and we have a lot with this one. It really is a lot because we're working with multiple classes. So the last little thing that you have to add besides having a tester is an interface. An interface is super easy, just like all of the other object-oriented stuff. Hardly any code. It's just the concepts that are kind of interesting. So what is an interface? Well, just basically, it's a named set of abstract members. So as you read through that chapter, a lot of sentences are going to be like this, where you go, huh? And then you have to kind of back up and reevaluate what they mean. What do they mean by abstract members? They mean methods that have that abstract keyword, so they don't provide a body, no default implementation. Those are abstract. So all an interface is some abstract method definitions. So an interface expresses a behavior, and we can have as many interfaces associated with a class as we want. So that kind of removes a limit we have with C#, because with C# we can only inherit from one parent, right? So our class can only derive from one other class. But when we add interfaces in, now all of a sudden we can implement all of these other interfaces. So we could add all these additional behaviors. So here is an example that they have in our chapter. They create this class called clonable type, and they say, what if this clonable type class had a method, an abstract method declaration for a method named clone? Well, now if we want to use this clone method, we want to implement it, we need to inherit from the this clonable type class. That's our only way, really, if we have to get that exact clone. So if we use an interface instead, we can get away from that. So here's an example of somebody trying to implement that clonable type. They have a minivan class and they want it to inherit from a car class. Problem is, they can't inherit from the car class and this clonable type class together because C# won't let us inherit from two different parents. We can't do it. So instead, we're going to make that clonable type into an interface. Now, interfaces in C# start with an uppercase I. They have the keyword interface instead of the keyword class. Other than that, pretty much the same, and that's about all there is to them. After the interface header, we have our opening and closing curly braces. Within our opening and closing curly braces, we have method headers, method declarations. Now this one's real basic. It says the method name is going to be clone, and it's going to return an object of type object. It doesn't have any parameters. Now, if my clone method had parameters, I would list them here. And then every time I implemented this interface, I would have to have the same declaration for my clone method. Why do we want to do this? There's lots of reasons. One I want you to think about is, say you're in charge of a project and you have 20 developers working for you, and each of them are going to be establishing many different classes. And you want to make sure that every single one of them implements a method. What do we want that method to be? Let's say our method is going to be updated date. And we want every time something gets updated, we want to make sure that the date on that database table row is updated with the date that it was updated, okay? So we're just going to do auditing on our database table and make sure that we always have this updated date. Well, in order to ensure consistency amongst our programmers, we can say we're going to implement this interface called, I update, and in there we say you must have a method named update date that returns a string, and then that way we can look through any of our programmers' code and find that method. We don't have to be looking for a bunch of different methods. Did they implement that properly? Oh, Joe implemented it. He always calls it Joe's update. And Sam implemented it. He always calls it A1Z. I don't know why. This guy implemented it. He always calls it some pop it out or something like that. Now I know all my developers have used the same exact method name for this behavior. You updated a row. I want that date updated. Why do I care? Well, because if I'm looking through all that code, I want to be able to find that right method. Or maybe I want to write a program that uses several of these different classes, and I want to be able to call that method from my overall program. Well, as long as I know that they've all used that interface and all named everything the same, I can use that same method name. So by implementing an interface, we can enforce consistent behavior among our project or developers. Now, in this case, they're using the interface to create a method that could be called from several different places. So if you look through the chapter, you'll see they've got a lot of references to that where they're calling from all sorts of different places to use a clone. When we create an interface, we're actually going to be adding a new item to our project, and it is an interface type, just like a class. It's saved as a CS file, though. Once you get it in there, it'll look a lot the same as any other CS file. And here's how we implement one. They have this interface called iPointy, whether or not things are pointy or not. And all of these different object types are implementing it. So in our class statement, we have a class name followed by the colon and the primary parent that it inherits from. Then we have a comma, and after the comma, we list any interface names that are going to be used by this class. So in our case here, the switchblade is pointy, so it implements the iPointy. The fork is pointy, it implements I pointy. If we had a spoon, we would not implement I pointy. So we would just implement it if necessary. So interfaces really give us a lot of flexibility. It's surprising that they do, even though all they're really doing is declaring a method for us. Let me show you one other thing here, if I can get to it. There it is. So in your text, they have a class diagram for the way they implemented that I pointy. They don't give us a lot of details, but here are all of our class structures that we have in our project. And here's the interface. Notice the interface has no data elements, no properties, no constructors, nothing like that, just a list of method headers. Let's see, it should show us. I'll let you guys mess with that in the class diagram because it will kind of draw an interesting line with your interface. We'll try it, but I wanted to give you guys time. So as you work with your sports team, the interface that you have to implement is supposed to have something to do with budgeting. So can you think of something that you could create as an interface that would be reasonable? You could design things many different ways. You could create an interface maybe named iBudget, and in there put a method called annual expenses, where the class has to return how much this team spends annually. You could do something along those lines. You could say trip estimate could be your method that has to be declared, and then in your individual classes, you could implement that trip estimate and return an amount. Say it's $5,000 every time you take a trip, however you want to do it.
Can an interface class have more than one method?
Yes. So you could have several listed in there if you wanted to.
And then each class that inherits from it would, by definition, have to have each of those methods.
Each of those, and they would have to have each of those in exactly the same way they are in your interface. So say you said this method required a string parameter and an int parameter. Those would have to be included in the method definition when it was declared.
It sounds like it really is mostly just an organizational tool.
I feel like it is a way for you to say, everybody will do this.
I wasn't done yet. I was getting ready to say, if you're working on a project by yourself, it's probably not really that necessary. You can just make sure. And because you yourself wrote it, it doesn't matter what it's saying because you'll remember it. It's mostly if you're working with a lot of people. It's just enforcement.
And it gives you a way to put a name out there that can be called by others, and they can know that that method name is going to exist in this class. So if they're working with an employee record and you always have a get last updated method, they can say employee.getLastUpdated method without having to go through and look and see what that method. Kind of like with our C# stuff, where the method names are very consistent. But yeah, kind of enforcing a traffic cop sort of thing to enforce that all of the method names are the same, the way that we want. For Wednesday, our schedule is a little tight because we need to present our different sports teams and we have our unit exam. So there's a couple of different ways that we can do that. So I'm thinking that we'll do our presentations when we first get here, and then we'll have our exam at 8:50, if that will be acceptable to everybody. Got your practice exam out there. Can you see everything? Is it all working? Nothing broken? Let's look at your hands-on exam before we break for you guys to work. I hope you like your hands-on exam. I really like this one. And maybe I like the casino, I don't know. But it's a slot machine one. And I think that I like it because I've had people do such great things with it. Now, this application is pretty open. You don't have a lot of specs here for this one. That's the more advanced you get. So for this one, it says it has to use a class somewhere. It has to use images, at least 10 of them. 2 of a kind awards, a dime, and 3 of a kind awards, $1. It doesn't say anything about how your credits work or anything as far as your interface. So it's totally kind of up to you how you want it to work. This is due a week from tomorrow. We won't present it in class, but I will take executables and copy them to a folder and share with everybody so that we can look at them after we've had a chance to recover from our exam. So this is not due this week. You can start working on it after you've got your sports team out of your way and presented it on Wednesday, and then you'll have like almost a whole week to get it done. Questions about this one? I think it should be pretty much however you want it. So I hope you kind of have a good time with it because you've got all this great knowledge about doing all these things. Make it look better than this one because that's silly form name. You can, I know you can. So that's what we've got. Wednesday, we'll do our presentations for our sports teams, each group, and then at 8:50, we'll do our exam. The exam is the same question banks as the practice exam. I can find it. There it is. And it doesn't really, as we've talked about, it doesn't match your book ideally. So make sure you've looked through that practice exam a few times because there's the same concepts, but definitely some different wording, different stuff to try to make it fun for you. Okay, if you don't have any questions, then let's just split up and start working on your projects and